Hello, welcome back. This is your Professor Sudha Parambil. In this section, you are going to learn about parabola. You will learn how to graph parabolas with vertices at the origin and when the vertices are not at the origin. Also, how to write the equation of parabolas in the standard form. Also, we can do applied problems involving parabolas. Do you know that the Olympic torch is lit several months before the start of the games? The ceremony of lighting the flame is same as in the ancient times. The ceremony takes place at the temple of Hera in Olympia, that is in Greece, and it is rooted in the Greek mythology. They use parabolic mirror and the sun's heat to light the torch. Parabolic mirrors are capable of capture energy and focus it on a single point. Advantage of this property are evidenced by the vast list of parabolic objects we use every day. Some of them are satellite dishes, suspension bridges, telescopes, microphones, and car headlights. Parabolic reflectors are also used in alternative energy devices such as solar cookers, water heaters, because they are inexpensive to manufacture and need little maintenance. Let's learn more about the parabola, how the equation and the graph look like. I usually think parabola as a U-shaped graph, but it can be open up, down, open to right or open to left. If it is open upward, the lowest point in the graph, that is known as the vertex, and focus will be always inside the U-shape. If the vertex is at 0, 0, the distance from 0, 0 to focus, that distance is P. So here focus is on the y-axis. So this distance is P. There is another line here. You can see here there is a horizontal line here. That also will be equal distance from the vertex. So equation of this line will be y equal negative P. That means this distance is P, this distance is also P. For x-axis, equation is y equals 0, right? If this is P unit downwards, that is the equation of the directrix, that is y equal negative P. And latus rectum, that's a line parallel to the directrix, but it is going through the focus. So this distance, that is the length of the latus rectum, that is 4 times P. If xy be a point on the parabola, its distance from the focus to that point and the directrix to that point will be always same. So using the distance formula, we can derive the formula for the parabola as x square equal 4py. I'm not going to derive that formula right now. If you are interested in learning the proof, please refer the textbook. So if you have a parabola open upward with vertex at 0, 0, the standard equation is x square equal 4py, where p is the distance from the vertex to the focus. If the parabola is open downwards with vertex at 0, 0, then the focus will be inside this. So the distance from vertex to the focus is p units. Since it is below the x-axis, the y-coordinate will be negative p. Right? Directrix will be always opposite side of that, but the distance will be same. So this will be p units above the x-axis. So the equation of the line will be y equal p. Here y-axis is the axis of symmetry, because if you know one piece of the graph on the left side of this axis of symmetry, we can draw the other piece because it's like a mirror image of that. That means the distance will be same. So if you want to know the coordinate of the latus rectum, so latus rectum, that is this line, we need to know the endpoints of latus rectum. What will be the endpoint? It will be equal distance from this one, right? Total length of the latus rectum is 4p, so it will be half of that distance. So 2p on the left side, and this length also 2p. So x coordinate will be 2p and y coordinate, that's the same, there won't be any change. Since this is on the left side of the y-axis, this will be negative, this will be a positive number. If the graph is open right side, this vertex is at 0, 0, focus will be inside this. So this distance is p So p comma 0, because this is on the x-axis. And the directrix also will be the same distance from 0, 0 on the right side. So this distance is p units. So the equation of the directrix will be x equal negative p, because that is the equation of the vertical line through negative p. If it is open left side, the equation will be y square equal negative 4py, because focus is at negative p, it's on the left side. And the directrix will be opposite side of that. So the equation of the directrix is x equal p. Let's do an example with vertex at 0, 0 and x-axis as the axis of symmetry. So the equation is y square equal 24x. If the equation is starting with y square equal 4px, so it will be a parabola upon right side. If it is y square equal negative 4px, then it will be a parabola upon left side. If the equation is starting with x square, then it will be a parabola upon upward. If it is x square negative 4py, then it will be a parabola upon downwards. So this is what I know already. Okay. So the equation, if you compare this, correspond to y square equal 4px, right? So 24 is 4p. So 24 equal 4p. Now I can solve for p. So divide both sides by 4. So p equal 6. Now graph this. Vertex is at 0, 0. It's a parabola upon right side. Focus is 6 units from the vertex. So 6 units from the vertex. This is 6 unit. So the coordinate of the focus will be 6, 0. And directrix will be 6 units on the other side. So directrix is a vertical line through that. Use a dashed line to represent the directrix. Always write the equation. Equation of a vertical line is x equal. Since it is on the left side, this is crossing through negative 6. So x equal negative 6. This is the directrix. In order to graph this, I know this is U-shaped graph, but I need to know whether this is this much wide or this much narrow. I don't know. So I need to figure out that. So I can use the latus rectum, that information. That means this total length should be 4p. That means from here to here, this point should be 2p. And this distance also should be 2p. 2 times p is 12. So I need to measure 12 units up, 12 units down to locate that point. Then join that and graph. After measuring 12 units up, 12 units down, I can join the points with a curve. So that is the parabola. A line through these 2 points, that is the latus rectum. Length of that line is 24. This is the focus, this is the directrix, this is the vertex, and the axis of symmetry, that is the x-axis. This is the graph of y square equal 24x. Let's do another example. This one, the equation is starting with x square equal. So if it is starting with x square equal, that means I know that it should be a parabola upon up or down. If there is a negative in the equation, that means that is a parabola upon downwards. So the standard equation is x square equal negative 4py. So I can compare that with negative 4py. So y is matching, x square is matching. So now what is negative 4p? So negative 4p is actually equal negative 6. So p is equal negative 6 divided by negative 4, that is 3 over 2. We can start graphing. So vertex is at 0, 0. It's a parabola up and downwards. So if it is up and downwards, the focus will be inside this. So the graph will be like that, right? We don't know how much width it is going. It could be like that or it could be narrow. We need to find out that. But focus will be inside that. So focus is 3 over 2 units downwards. So the coordinate of focus will be 0, negative 3 over 2. Directrix also will be 3 over 2 units, but it's on the other side of that. So this equation will be y equal 3 over 2. That is the equation of the directrix. Now we need to know the coordinate of these points, like where exactly the graph is crossing. Total length of this one is 4p. So this will be 2p, 2 times p. 2 times p is 3. So the coordinate of this point will be 3, negative 3 over 2. Because y coordinate won't change, right? It is still in this line. So y coordinate will be the same. This is also 3 units to the left side. So it will be negative 3 over 2. Here axis of symmetry is the y-axis, and this is the graph of x square equal negative 6y. Now let's learn how to graph a parabola if the vertex is not at 0, 0. That means vertex is at some point hk, and here we can actually use the basic concept we just learned to graph. But if you are interested in learning the formula, you can refer the textbook and you can follow that. I don't like to memorize too many formulas, so I'm going to use the basic concept, whatever I learn. Then I can shift the graph based on where the vertex is. I'm comparing the question with of the form, this is y square term is there, then there is a negative, then x on the other side. If I have an equation starting with y square, that means the parabola should be open to the right, or it could be open to the left. If there is a negative sign in the equation, it will be a parabola open to left. So this is not the shape of the graph. I need a graph open to the left. This is the standard equation when the vertex is at 0, 0. If the vertex is at hk, so it will be this correspond to the x coordinate, this correspond to the y coordinate. So the equation I can transform to y minus k square and 4 times p x minus h. The similar technique used in ellipse and hyperbola. Okay, so we can compare this with the given question. So y minus 1 whole square negative 16 x plus 3, right? So if you compare that, you can see that h equal 1, x will be negative 3 and 4p is 16. From that you can solve for p. We can plot the vertex first. So this is at 0, 0. So measure negative 3. So 3 units left, 1 units up. So that is the vertex. Then measure 4 units left, so that you will get the focus, and 4 units to the right to get the directrix. So if you measure 4 units to the right, if you measure 3 units to the right, you will get the y-axis, then 1 more unit, right? So equation of the directrix will be x equal 1. We can measure 2p units from this point. That means 2p is 8. That means measure 8 units up, 8 units down to get the end points of the lattice rectum, and join that and draw the curve. And the line through the focus and the vertex, that is the axis of symmetry. Graphing a parabola from an equation given in general form. So this is the general form. We need to write in the standard form first so that we can graph this. This is starting with the x square and y don't have any square. So we can compare this with the standard form. X minus h whole square equal 4p y minus k. First rewrite the question. Keep only the term which has x on one side and move the other term on the other side. Then we need to add a constant so that this will be a perfect square. So take the coefficient of x, divide by 2 and square that. That will be the constant you will be adding to make this as a perfect square. So we can add 16. So if you are adding 16 on one side of the equation, add the same constant on the other side. Then write this as a factored form. So that is x minus 4 whole square. Add the constant, that is 224. Here 28 is common factor. So factor 28. And we are comparing with this standard form, right? So 28 you can factor it as 4 times p. So this 7 will be the p. From this we can identify h and k. So h is 4 and k is negative 8. I copied down the formula into this page. So we were comparing this formula with the standard form, and p is 7 and this is hk, that is 4 negative 8. Since p is positive, or this whole term is right side is positive, that means this is a parabola open upward. So we can start graphing by vertex first. So this is 0, 0. So measure 4 units right and 8 units down to get the vertex. Then you can measure P is 7 units, right? So 7 units, measure 7 units up and 7 units down. If you measure 7 units up, you will get the focus. If you measure 7 units down, you will get the directrix. Directrix is a horizontal line here. So the equation will be y equal negative 15 because negative 8 minus 7, that is negative 15. If you add 7 units to that, negative 8 plus 7, that will be negative 1. So the focus coordinates are 4, negative 1. Now we need to decide how wide is this parabola. So we can find 2p. So this distance is 2p on each side. Add 14 to this to get 18. So 14 plus 4, that is 18. Y coordinate won't change because that's the same y coordinate. Here also y coordinate will be the same, but you need to subtract 14 from that. So 4 minus 14, that is negative 10. So now we got 3 points. Now join that and draw the curve, that is the parabola. And axis of symmetry is a line through the vertex and focus. So that is the vertical line through the point 4. So the equation of the axis of symmetry is x equal 4. Now let's do an application problem. The cross section of a design of a travel size solar fire starter is shown in this figure. The sun rays reflected off the parabolic mirror towards an object attached to the igniter. So igniter is here. Because of the igniter is located at the focus of the parabola, so this is the focus. The reflected rays cause the object to burn in just seconds. Find the equation of the parabola that models the fire starter. Assume that the vertex of the parabolic mirror is at the origin. That means this is at 0, 0. Use the equation found in part A to find the depth of the starter. This is a parabola open upward. So I'm viewing like that. So the standard equation is x square equal 4py. We know the p, right? We know this distance from the focus to the vertex. Vertex is at 0, 0. This point is, we know that this distance is 1.7. So this point is 0, 1.7. So p is 1.7 y x square. So I got the equation. I can just multiply this and write it neatly. So if I multiply, I'll get x square equal 6.81. So this is the equation of the parabola. So we got the answer for part A. The width of the dish is 4.5. So this length will be half of that. That is 4.5 divided by 2, that is 2.25. So when x is 2.25, we need to find the corresponding height, that will be the depth. So in our equation, we can replace this x with 2.25 and solve for y. Divide this value by 6.8, you will get y is approximately equal 0.74. So we can conclude our answer. The dish is about 0.74 inches deep. In this section, you learned the equation of the parabola vertex at 0, 0. If the equation is starting with y square, it could be a parabola upon right or left. If the equation has a negative sign, it will be a parabola upon left. And if the equation is starting with x square, that means it will be a parabola upon up or down. If it has a negative sign, it will be a parabola upon downwards. If the vertex is not at 0, 0, you can replace this x and y with x minus h and y minus k. Then the vertex will be at hk. Also you learned the distance from the vertex to the focus and vertex to the directrix will be of same length, and the length of the lattice rectum is 4p.